Now, lesson 8 deals with how to deploy the Webex Edge Video Mesh server solution. So during this lesson, I'm going to talk about the Webex Control Hub initial configuration steps, because that's where you're going to begin. Then, and that's just to download your OVA template. Then you're going to take that OVA and log into VMware vSphere ESXi and build a virtual machine and configure settings for that virtual machine. Then you want to complete your Webex Control Hub configuration step. So once you've built that VM, you got to register it to Webex Control Hub. Then if you want CUCM registered endpoints to be able to call into the Webex Control or to the Video Mesh node, you have to build that side of it too. So we'll talk about how to configure UCM components. And then I'm going to cover some troubleshooting meetings. All right, so let's go ahead and dive into Video Mesh. Again, we're talking about how to set it up. So first thing you want to do in the Webex Control Hub is you want to download your OVA template. So for this, you navigate you log into the Webex Control Hub by going to admin.webex.com, log in, and in the menus in the left-hand column, you want to select Services, and scroll down and look for the Video Mesh card. Click Setup just like you would with any other hybrid service, and it'll take you to a screen that says before you register your Video Mesh node, you must install and configure the software on a server, and then it'll ask you, yes, I'm ready to register my Video Mesh node, or no, I need to install it first, right? So if you check no, I need to install it, then it's going to ask you, this won't show up until you select no, do you want the full-blown production deployment, or is this just like a trial? You're trying to test it first to see if you want to buy the licenses for it necessary. Is it a limited 90-day demo, right? You do have two options there. If you're just demoing it, choose the 90-day demo. If you bought the full capacity license, full-blown everything, you can check that one. The OVAs are a little bit different, but even if you do the demo, you can convert that over later to the full-blown. It's not a big deal. Then you click Next, and it'll just automatically start downloading the file for you, right? Cisco does suggest that you leave this window open just to make sure it downloads completely first, because if it doesn't, it gives you the option to hit try again, but it's not a big deal. You just hit OK, and if it messes up and it doesn't download, just go back in under the Video Mesh card, click Setup, click No, click Next, download it again. It's not a big deal. So if you don't mind going through a few extra clicks and steps, then you can go ahead and download or just close that window, right? Click OK. Once the Video Mesh node OVA template has downloaded completely, now you need to log into VMware ESXi and build your virtual machine. So to do this, in the menus at the top, you select New, Deploy OVF Template, and it'll take you to a screen that looks like this. Click Browse and select the OVA file for the Video Mesh node that you just downloaded. And then at the bottom of this page, you click Next, and it takes you to a confirmation page. It's reading the information in that OVA file, and it's making sure that you selected the correct file, right? It's going to show you things like download size. You can make sure you have enough hard drive space to be able to support it, size on disk, how much space it's going to take up once you actually build this VM. These are the preset partition perimeters. It's going to create a partition with this amount of space, and you want to make sure that you have enough hard drive space before you install it. So just read this information. Nothing really to change here. If everything looks okay, you scroll down to the bottom of the page and click Next. Then it allows you to give the the virtual machine, a name. Call it anything you want. It doesn't matter at this point. This is just for your own management purposes. So you can actually look through a list of virtual machines on your server, and you can say, you can know exactly which machine is what and what it's doing and so forth. Right. This isn't the DNS host name or anything like that, although that is a good that would be a good name to use for naming your virtual machine. Call it anything you want. So I call it VMN1, for example. Then you come over to, when you click Next, you got to choose a couple things here. First of all, you want to choose the data store you're going to download the OVA file to. Most VMware setups only have a single data store set up, but you can set up multiple data stores too. It just depends on how it was deployed in the first place. So if you've only got one data store, like I do in this example, then I don't even have a drop-down menu to choose another data store because nothing else is available. If you have multiple data stores available, then you may have a selection option there as well. Also, it'll say available size, so you can actually modify this if you want. And you want to choose your provisioning mode. Cisco recommends thick provisioning lazy zeroed. I could explain the difference between these different provisioning modes to you, but honestly, it doesn't really matter, and we're kind of short on time, so I'm just going to press on past that. What Cisco recommends is that you use thick provisioning lazy zeroed, and then click Next. Then you choose your network. You can choose an internal or external network interface, depending on what you have set up. Usually for Video Mesh Node, you're just going to choose internal network. Click Next. You have a confirmation page of everything you just configured. You can click the back button to go back and change anything. You can also click on any of these hyperlinks to go back to a specific field if you wanted to change settings. I also recommend you go ahead and tick this box that says power on after deployment so that as soon as it's finished building the VM, it starts it up right away. Then you click finish. It'll go through. You can actually watch the installation process with a little counter bar that'll show up. And then once it's installed successfully, you'll get this confirmation window said completed successfully. Click close. And now you can go in and configure your Video Mesh node. So to do this, there's a couple ways you can go in. You got to go into the console. You can just select your Video Mesh node from the column on the left. And then right here you see these tabs. You'll have a tab called Console. You can go and click on the Console tab, and that'll have an embedded console window that allows you to console into your virtual machine. You can also do this from the menus up top, but the way I prefer to go in is to right-click on Video Mesh Node and come down to Open Console, and it opens up a separate console window. Now, if the Video Mesh Node just booted, it's going to take it about 5 minutes or so to fully boot up. It does take a while, especially on the first time boot. So what you want to do is just watch this screen until you see something that looks like this. It'll say login, and give you a login prompt. That is not when you want to log in. You want to wait. And pretty soon it'll start scrolling the boot up lines of information again. And at some point later, it's going to say Cisco ECP dash, and it'll have this long serial number here. And then it'll say login after that. This is your indicator it's done booting. At this point, it has booted enough where it will allow you to log in. If you try to log in before that, you'll start to be able to log in. All of a sudden, these lines are going to mess you up, and you're not going to be able to do anything. You're going to have to wait until it gets to this point anyways. So save yourself the trouble from the beginning. Wait until you see this Cisco ECP long number login prompt. Then you can log in. The default username and password to log in is admin Cisco, all lowercase. All right? Then as soon as you log in, it'll prompt you to create a new password. So it says change the password for admin. What's your current password? Current password was Cisco, all lowercase. So you put in the current password, then it'll say new password, and then re-enter new password. So that's where you create your new password. Then after you get to that point, it'll actually go to a screen that looks like this. And it's just kind of giving you a warning message here. Just click OK. Now, you cannot use your mouse at this point because you're still in the console window. So you can use the arrow keys to go through menus, and you use the tab key to go through submenus. To make a selection, you can press enter or the space bar. So for example, you have this list of menus right here. To scroll through these menus, you want to use the arrow keys to make your menu selection, right? If I wanted to go from these menus down here to where it says select or exit, that's how I'd use the tab key. To go from menus to select to exit, back to menus, back to select, back to, I just hit the tab key to get through those, okay? So sometimes you'll use arrow keys, sometimes you'll use the tab key. So arrow key down to edit configuration, then use your tab key to go to select and press enter or spacebar. That'll take you to the next screen. It says, are you sure you want to proceed? You can press spacebar to select yes, or hit tab to go over to no, and then hit spacebar. So it just depends there, right? But that'll end the setup wizard, so you don't want to do that. So select yes, I want to proceed. Do you want to do static or DHCP? You should always set a static IP address up on your video mesh node. So choose static, press space, and then it'll take you into the edit settings menu. You want to use the arrow key to go down through all these different submenu options here. You want to give it the host name. Now the host name matters. This is the DNS host name that is set up in the DNS server for your video mesh node, which hopefully you've already set up prior to configuring these settings. Then you want to put the domain that's used in DNS for your video mesh server. Then you assign it an IP address, subnet mask default gateway, put in your internal DNS IP address, come down and put in at least one NTP server address. Cisco recommends you do at least 3. There's 5 NTP server address options available. Once you've configured all these settings, you hit the tab key. It'll come down to save. You press enter or spacebar. It'll take you to this confirmation screen. Once you've confirmed this information, hit the spacebar to save changes and reboot. You'll see this done message right here. You can hit the spacebar again, but basically at this point your server is about to reboot itself. Okay? So that's it. That's configuring the video mesh node. Now that the video mesh node has been installed and configured, you have to now register it to your Webex Control Hub. So you go back to the Webex Control Hub. You go back to the services menu on the left, select the video mesh card, click setup, and now when it asks you, are you ready to register your video mesh node, you select yes, hit next, and it says, do you want to create a new cluster? You have to create a new cluster if this is your first video mesh node. If it's not, you can select the old video mesh node cluster and just add it as an addition to it. In this case, we're creating a new cluster, so we have this radio button selected. We give the cluster a name. We come down and put in the URL or IP address of the video mesh node, and we click next. Then it's going to go through a couple other setup screens. I'm not going to go deep into these. You can read the deployment guides if you want to know a little bit more information, but first you have a service configuration menu. You can enable 1080p video, for example, if you want. You can enable media encryption, which you would need to do if you're using SRTP or a secure SIP trunk security profile in your CUCM. Then you're going to have to enable media encryption, but you have to have trust certificates set up and all of that first, which we talked about before, right? This is part of the piece that you would configure in the Webex Control Hub. Then when you click next, it takes you to the upgrade schedule. The video mesh node will upgrade automatically, and there is a default schedule in here that comes pre-set up. If you want to change these settings, you can, but otherwise if you click next, it's just going to upgrade the video mesh node in the future based on these settings. Now, because you're installing it for the first time, if there's an upgrade available, it will upgrade it immediately because it's the first time you installed. But after that, it will not do a full upgrade until this scheduled set time. Okay, click Next. Again, we have some more SIP TLS configuration setup components. This will be grayed out unless on this first screen you enable media encryption. If you enable media encryption here, then there are some settings you have to set up here that says, yes, I've built these trusts, and yes, I want to do a secure calls only, right? Then when you click Next, you'll see a screen that looks like this. It says your registration's complete. We need to go to the manage this node. So you click, I think I have this backward. I'm sorry. Go from left to right, not right to left. I had these in the wrong order. Right here, continue to the video mesh node registration. You click go to node. Takes you a screen that looks like this, just like when we were setting up connectors on the Expressway core. You want to check the allow access to Webex Video Mesh node so that the Webex Control Hub can take control of this server, right? Manage certificates, it can update it if it needs to, all of that. Once you click allow access to Video Mesh node and click continue, you'll see a little scrolling thing, and then you get this confirmation window that says Video Mesh node is registered. And that's it. That's registering a Video Mesh node to the Webex Control Hub. After you do that, just because you have the Video Mesh node configured does not mean that you can actually use the Video Mesh node for conferencing. There is another setting you have to configure there first. So once again, just like we did with Edge Audio, you want to select the services menu on the site. Under Meetings, you click Sites, select the site from the list, and then you'll see that little flyout window on the side. You want to click Configure Site. That's what you see in this first diagram right here. And then that will take you to those common settings again in the Webex management interface. Now, instead of selecting, last time we selected Edge Audio right here. This time, because this is Video Mesh, you want to select Collaboration Meeting Room CMR, right? And when you make that selection, you see these settings. Right at the top, you'll see something that says Media Resource Type. This defaults to Cloud. You have to change this setting to Video Mesh node, or your Video Mesh nodes will not be used. All right. Remember how I was saying Webex Teams clients and Webex registered endpoints will automatically search for they'll try to use the Video Mesh nodes first? That's because this setting tells them to. If this setting is set to cloud, they're only going to use the cloud. They'll never use the Video Mesh node. And even if you have an on-prem SIP trunk on the CUCM pointed to the Video Mesh node, that Video Mesh node cannot be used because the cloud is not aware that it's supposed to be used because this setting hasn't been changed. And it'll deny all communication if you try to use that Video Mesh node. So you have to do this setting. This is, I said this before with Edge Audio, now I'll say it with Video Mesh node. This is the #1 reason why I see calls fail to a Video Mesh node is because people forgot to change this one tiny little setting. This one setting right here will break it every single time without fail. So make sure you change the media resource type to Video Mesh and then click Update, and now the Video Mesh node can be used. It can be used by Webex Teams clients, and it can be used by Webex registered endpoints. It cannot be used by on-prem endpoints because you have to build the CUCM SIP trunk to point to the Video Mesh node. So that's what this next section is, right? How to get the CUCM endpoints to use the Video Mesh node. So just like when you're creating a SIP trunk for Edge Audio, you have to create the same general components for Video Mesh as well. So you go in and create a SIP trunk security profile. Notice the setting in the SIP trunk notice the settings in the SIP profile are the same as the settings in the SIP profile you created for Edge Audio. So you can use the standard SIP profile for Edge Audio if you set that up also for Video Mesh also, because the settings are the same. You just want to come down to early offer support for voice and video calls and set that to best effort, no NTP inserted. You also need to create a SIP trunk security profile that you're going to use to point to your Video Mesh node. Again, you can use secure or unsecure SIP trunk security profile, but if you use secure, you have to build trust between the certificates on the CUCM and the Video Mesh node. Then you want to create your SIP trunk to your Video Mesh node. Important settings to configure. You want to give it a name, obviously, with no spaces. You have to do a device pool. It doesn't matter what device pool you use. It's not like with Edge Audio where you have to use G.722 or G.711. It's not like that. You can use any device pool, anything you want here. Nothing specific you have to use. But you do, by CUCM definition, have to select a device pool because with the asterisk you can see it's a required field. Down here under calling and connected party info, it would behoove you to change the setting to deliver URI and DN and connected party if available. Then you put in the IP address or URL of your Video Mesh node with appropriate port. Choose your SIP trunk security profile you created. Choose the SIP profile you created, and then save the settings. You do not have to do a SIP normalization script with Video Mesh node. Then you want to create your route groups, route lists, and SIP route pattern. So for your route group, make sure what the trunks that you add to your route group are the Video Mesh trunk, and you may want to put another trunk in there that points to your Expressway core, Expressway Edge, so that, like for example, when you set up Edge Audio, you can add that trunk in here. And what that allows you to do is, if calls cannot connect to the Video Mesh node because you're out of resources, they can be redirected out through the public internet and then connect to Webex in the cloud, right? And make sure if you add both trunks in here that the distribution algorithm is set to top down. You don't want to use any kind of distributed or round robin type thing, because you always want it to go to the Video Mesh node first, and only if that fails, then go to the opposing trunk here. Then you want to create your route list, add your route group to your route list. And then instead of creating a route pattern, what we're going to do is create a SIP route pattern, because the Video Mesh node uses a SIP URI in every instance. And so for your SIP route pattern, you can click New. For the route pattern, you just put star.webex.com. It means anything.webex.com will route using this route pattern. SIP trunk, you want to choose the Video Mesh node route list you just created, and then save those settings. Okay, let's talk about troubleshooting meetings. Real quick, as I said before, I did do a full 1-week course, custom course on Video Mesh, and I wanted to take some of what I covered in troubleshooting there and include it here for you as well. So there's a lot of different tools available that administrators can use to troubleshoot Video Mesh nodes, and the Webex Control Hub also provides analytics, alarms, and events that are related back to Video Mesh nodes as well. So a lot of tools available here for you. The Webex Video Mesh node now has a web interface. So if you weren't aware of that, just note that there is a web interface now, and it also has a lot of tools available that can help you troubleshoot and monitor the overall health of your Video Mesh nodes. There's also alarms and notifications, connectivity checking, log captures, packet captures, all designed to help you troubleshoot these systems related back to the video mesh node. The Webex Teams clients also have logs available, which can be accessed on the computer the application has been installed on. So from the Webex Control Hub, this is kind of an example of some of the analytical data that can be captured pertaining to the video mesh nodes. Analytics provide information about how your video mesh nodes are being used on premise. There's historical data in these metrics as well, and it allows you to more effectively manage your video mesh resources by monitoring things like capacity, utilization, availability of your on-premise resources. You can use this information to make decisions about if you need to add more video mesh nodes to a cluster or create new clusters in different environments. So Webex Video Mesh Analytics can be found in the Control Hub under the Analytics menu in the left column, and then select Video Mesh. And you can also go to Troubleshooting Recent Resource Usage to find data as well. So when an administrator views a video mesh resource in the Webex Control Hub, if there's an alarm active, then the word alarms will appear beside the resource status. Selecting the video mesh node with the alarm will allow the administrator then to be able to view the severity of the alarm along with an alarm description. So in this example, it doesn't say alarms, it just says warning. And that's just because it was a demo video mesh node where this capture was taken, and the server where it was built didn't have enough CPU space for a production environment, so you get a warning message on that. Not a big deal. But this is kind of an example of how you will see that information and how it's relayed back to the Webex Control Hub. Now, alarm notifications allow additional information to be viewed, which are related to error messages such as error codes. And one such error code relates to microservices that continuously run in the background on the video mesh node. So quick note about these microservices. There's 5 different microservices that run. And there's a UR built into the video mesh nodes. And what's happening with these microservices is these are different places. They might be AWS server is one of them. I think there's a Google server is another one. They're not all in one location, but there's different engineers within Cisco. They're responsible for updating different components of the video mesh node, and they basically manage these different microservices. So when your video mesh nodes are upgrading, it might just be one particular service upgrading. It's not an overall video mesh node upgrade, right? And these can happen in the background while the video mesh node is running. But the video mesh node has to be in constant communication with these microservices, or else it creates an error message if it ever loses communication with one. So the codes you see in the right column here relate to each of these microservices. So if when you're looking at that error code, if it says something like LOC, this tells you it's this particular signaling URL or this signaling microservice where I've lost communication, and that's what generated that error code. So if it's related to one of these microservices, the error code you're going to see is one of these codes you see on the right column. All right. This is an example of the web interface you can go into on the video mesh node. Notice it shows you things like call status, number of calls currently going on in the video mesh node. You got node details, node health, register details, cloud connectivity, and network settings. These 6 boxes are always available, displaying information. This cloud connectivity check is performed every time the video mesh node boots up, for like first time it boots up or as soon as it boots up. And every time an administrator logs into this web interface, it will run through this connectivity check. And you can actually go in and view the status of each one of these. It'll say failed if or pass. If it says failed, you can highlight over it, and a little balloon window will pop out and show you what was checked and why it failed. On the right side here, notifications, this window will only appear if there are notifications that you need to be aware of. If there's no notifications currently residing on the endpoint, no error messages, nothing like that, then you will not see this notification window on the right column. It'll just be these 6 boxes that you see on that overview page. Let's see here. One of the great tools available for the Video Mesh Node interface on that overview page is that connectivity test card, which I just told you about. And an easy way to remember the information that's checked using this card is 234. You have 2 connectivity checking checkpoints. You have 3 primary tests and 4 testing destinations. So your 2 connectivity checking points are your initial deployment wizard and then each deployment of the Video Mesh overview page, right? And that's what I told you before. When does this check run? When you initially deploy the wizard or boot up the system, or each time you go to this overview page. There's 3 primary tests that are conducted. A DNS resolution test, a TCP connectivity test, and a bandwidth test. And there's 4 destinations. There's the idbroker.webex.com, hercules-a.webex2.com, index.docker.io, and amazonaws.com. Those are the 4 destinations you'll go to, and they relate back to these 5 microservices. So 2 of the microservices are in one location, and then the other 3 are in different locations. These URLs I just mentioned are the locations or destinations where they are located. If you want a description of each one, you can find that in the notes section of the student guide. There is a troubleshooting menu from the web interface of the Video Mesh. And these 2 tools are available for you to be able to capture logs and do packet captures and that sort of thing. Logs are captured automatically for all events on the Video Mesh node, whether systems are working or not. And these logs can be sent directly to Cisco for analysis by attack engineer, or they can be downloaded locally by the administrator in order for you to examine yourself. A deeper log trace can then be captured using the packet capture tool, and again, these PCAP files can be sent directly to Cisco or downloaded locally for analysis. Logs are written to the home/mfusion/logs/folder within the Video Mesh log. Logs are non-adjustable, meaning the information captured within a log file cannot be changed. The information in logs are also historical and persist reboots, meaning the information is not purged when the node is rebooted. When log files are sent to Cisco, an upload identifier should be provided to your CX support engineer. The upload identifier is an identification code used to be able to retrieve the log from an internal logging tool. So what happens is the log information, when you choose to send it up automatically to TAC, it goes into a general kind of server somewhere, data server. And then for the TAC engineer that you're working with to be able to pull your specific file, you have to provide them one of that identification code, and then he's able to pull down from that server the specific file that you uploaded. Information that's captured in these logs are useful for identifying connectivity to Webex, identifying platform issues, call setup, media issues, The packet capture utility writes information to the home Infusion packet capture folder on the video mesh node, and captures are taken from each interface and then consolidated into a single file. Packet captures should not be left turned on because they're really large in capacity and they fill up quickly, and that could affect the overall performance. So if you do turn on a packet capture, make sure you only have it enabled long enough to capture the error messages that you're trying to capture, and then to turn it back off. Let's see. When log files are downloaded, they are compressed into a file called logs.tar.gz. You want to use a tool such as WinZip or Unzip to unzip the file. Once you've gained access to the subfolders and documents, these log files can then be opened and read. So this slide is designed to provide a high-level overview of where the most relevant log information can be found. Another tool that can be found in the troubleshooting menu of the Video Mesh node web interface is the Reflector Tool. The Reflector Tool is used to verify whether the required TCP UDP ports are open from your Webex Video Mesh node. It consists of a combination of a server on the Webex Video Mesh node and clients that are available through a Python script. You can download a copy of the Reflector Tool client from a link I've provided in your student guide, and then you can unzip the file to a location that's easy to find, and then the zip file contains the script and a README file. For the script to work properly, you need to ensure that you're running Python 2.7.10 or later in your environment. And currently, this tool supports SIP endpoints to the Webex Video Mesh nodes and intra-cluster verification. So I think Cisco recently added, instead of you having to download the client, which you can still do, I believe they added the Reflector Tool into the web interface. So you can just go in and enable it and run it right there in the web interface of the Video Mesh node. You don't have to download anything using Python on your computer. Webex Video Mesh node interface, a web interface, has another troubleshooting tool that can be enabled called the Debug user account. If Cisco support requires access to your Video Mesh node, you can temporarily enable a debug user account so the support engineer can run further troubleshooting themselves. It gives them kind of a backdoor into your Video Mesh node. Each Video Mesh node has a built-in debug user account called Infusion, and this account is what's used by TAC in those special troubleshooting situations. The account can be enabled through SSH or console and through the web interface, but Cisco, the web interface is added more recently by Cisco, and once it's enabled, the account remains active for 3 days, after which time it will automatically disable itself. If you enable the account, you can disable it at any time also, just by turning it off, and then they lose access. So you do have full control over that. Once it's enabled, an encryption hash will be generated, and you have to supply that encryption hash to TAC in order to generate a password and access the Video Mesh node remotely. Without that hash, even with it enabled, they can't get in. And then finally, the Cisco WebEx Teams client that you install on your personal computer also has logs available that might prove beneficial in troubleshooting connection issues. If you're on a Windows computer, you can open a command prompt window and enter the command cd c:/ and then enter the command dir for directory /users/username/appdata/local /Cisco Spark, and that will take you to the log files. Cisco Spark was the former name of Cisco WebEx, so that's why that's still in that name. There's also a way on an Apple computer you can get to it. It's probably the simplest way is just open a Finder window, and then the menus at the top, click Go, and then Computer, and then go into the users, username, library, logs, Spark Mac desktop folders, and then within that folder you should see all the log files related back to WebEx. Again, you want to locate either way the log.txt current underscore log.txt file for all of your call setup information. In the case of both Windows and Mac computers, the username is the actual name associated to the computer itself. And that is Video Mesh.